So this is the second part of this lesson, which is also going to be a double lesson. And we're trying to prove that this triangle is isosceles, meaning AB equal BC. And we said we need to prove that there's two triangles that are congruent, and it's these ones. Okay? Am I copying? Yeah. Is it working? Yeah. So we want to prove that the red triangle is congruent to the right triangle. And what we showed so far is this common side is equal to itself, obviously, because it's common. So we showed one side is equal. We also showed that the angle, one angle is equal. So I've got a side and an angle. I need another side. That's what I'm looking for. Now, you saw me, I kind of got stuck. I really did. I looked out, I don't know what else is equal. I really don't know what else to prove. When you're stuck and you can't really think about another thing that is equal, look at the information in the question, see if there's something you haven't used. And that's why I did, and I realized, you know what? I know that A1 equals C1, and I haven't used it. Now, these are angles not in those triangles that I'm trying to prove that they're equal. So I can't use them directly. But if I have I've got a triangle here, right? AFC, and I've got two angles that are equal. What does that mean? That means this one is an isosceles. Okay? Right? So if it's an isosceles, I know I've got two sides that are equal. Which sides are they? AF and CF. But these sides are actually in the triangle that I'm looking at, so I can use it. So let's write it down. I'm going to write A1 equals C1. Okay? That's just given. And then I can write, okay, if these two sides are equal, then I can say AF equal FC. Okay? And I've got to write down the reason. Should have used the red. Okay? Equal sides, opposite, equal angles. Okay? Alright, so now I've got a side. Now check this out. I'm just going to highlight for you. I've got two sides, looking again at the green and the red triangle. I've got two sides that are equal. That one equal to itself, that one equal to that one. And I've got the angle in between them. Okay? See where I put the little stars. These three statements help me to prove the triangle ABF, okay, is identical. Let's see if you can figure out which triangle it's identical to. ABF, okay, that will be congruent to angle. I'm just drawing it. Look at this. ABF. What is A2 equal? It will be to C2. So it's going to start, if I started like that, I have to do CBF. Okay? And how do I know what case am I using here? Okay? Side, angle, side. I've got a side, two sides. This one equal to itself, these one equal to each other, and an angle between them. Okay, why did I do that? They didn't ask me to prove that this triangle congruent, but now I can say the side AB is equal to side BC. Okay, so I can write AB equal to BC, and the reason is I just got to write again these triangles are congruent. So ABF congruent to triangle CBF. Okay. And then if these two sides are the same, well, that's it. I proved. Okay, so triangle, therefore, let's do it in red, therefore, you might even be enough to write that, but we can just say, therefore, triangle ABC is isosceles. Okay? Alright, I know it's tough, guys. Okay, let's do another question. Okay, there's a couple of questions here, and I'll get you to do at least one of them, where you've got triangles in a circle. Okay, we will do a lot if you do maths, pure maths, or what do you call it, maths instead of math lit, you will work a lot with that. Okay, but for now, just simple. So we are asked to prove that O1 is equal to O2. That's the first part. We are in question J, the same page. We're still in 162 J, just the last question. So we are told that these two sides are the same, okay, you can see, and we're also told that O is the center of the circle, very important, okay, we usually use the letter O for the center of the circle, and we want to show, first of all, that O1 is equal to O2. Again, this is the kind of question where they don't tell you explicitly to prove congruency, but you have to, okay, So I've got two triangles. Which one are congruent? Okay, I'll just draw one in red. Okay, you can see that the red triangle on the left is identical to the blue one on the right. So one thing already I know is the same. It's the side. So let's write that down. Again, all the ones, the left triangle on the right and the left, the right triangle on the right and the right. So AB equal to AC. Reason is given. Okay. Now, that's one side. Now, I've got, okay, I've got another side that is equal, isn't it? Okay. Which one is the common one? AO equal AO. Okay, obviously, because that's common. This side, it's just one side, but it's obviously equal to itself. So I've got two sides. Guys, if I can get one more side, I'm sorted. And I can. Okay? Why can I say that BO equal OC? How can I tell that? Not because it looks like it. But look at this. If this is the center of the circle, okay, a line that goes from the center of the circle to the edge of the circle is called what? Okay, you should know that. That's a radius. Okay? That is a radius. That is also a radius. Any line that goes from the center of the circle to the edge of the circle is called a radius. Now, what can we say about the radius? It's all the same. It doesn't matter if this is the radius, this is the radius, this is the radius. Okay? They're all the same. Okay? So the answer is both are okay, so we want to say radiuses, but in English you don't say radiuses. The plural of radius is radii. You know, to make it simple, I can't even spell that. So both are radius. Both are radius. Just write like that's fine. Okay, radii. I don't know how to spell radii. Okay. Anyway, we've got three sides that are the same. Therefore, we can say triangle. Okay, and I'm going to start with the left. I'm going to go AOB. Okay, so look what I've done. I've done AOB. Going to get rid of that stuff. Now, what triangle on the right I got to write? If I start from AOB, then I start with A here as well. AOC. AOC. Okay, so these two triangles are congruent, and the reason is SSS. Okay? Now, if I've got two triangles that are congruent, then I can say a whole bunch of stuff. I can say, for example, that those two angles are the same. Okay? What is this angle? It's this. Okay? So it's O1. So therefore, I can say O1 is equal to, what is this O here? That's O2. Okay? And what's the reason that these two angles are the same? Okay? It's because I got to copy again AOB congruent to a triangle AOC. Okay? Okay? So I've done the first bit. I've shown that these two angles are the same. The next part, they're asking me, they want me to prove that AO is this line to BC. Okay? Some of you ask me, what does that line mean? It means right angle, perpendicular. It means basically it's 90 degrees. Okay? That's what they want to show me. Okay? Now, how do I do that? Okay, I know that O1 is equal to O2. But I also know that O1 plus O2, if I'm adding these two triangles, I must get 180. Right? If I'm adding those two, I must get 180. Why is that? Because they're adjacent angles on the line. Adjacent angles on the line. Okay? But I know that O1 is equal to O2. So instead of O2, for example, I can write O1. So I'm going to write O1. Instead of O2, I'm going to write another O1. Okay? That's equal to 180. That means 2O01 equal 180. And that means O1 is equal to 90 degrees. Okay? So if O1 is 90 degrees, then AO, therefore, AO is perpendicular to BC. If this is 90 degrees, then therefore AO is perpendicular to BC. Okay? And the last question they asked me to show that triangle ABC is 90 degrees. Okay, this is actually, I'll just pause you here for a second, make some space. Okay, I'm just going to write it here. Hopefully I'll have enough place. They want to show me, in question 3, they want me to prove that triangle ABC is right angle. In other words, there's an angle here in this big triangle. Okay, I'll draw it in green now. We're looking at the big triangle. I want to show that's 90 degrees. So which angle is going to be 90 degrees? You probably guess it's this one. But I have to show it. It's a bit of a difficult one. So what I can do is say, okay, look, this is 90 degrees. Now, what can I say about the right triangle? Let's look at the right triangle. Okay? This is a radius, this is a radius. And radiuses are the same, isn't it? So I can say that AO is equal to OB. Okay? Both radii. Okay, let's see if I can. Radii. I think that's how you spell radii. R-A-D-I-I. Okay? Alright, so AO equal OB. Therefore, angle B is equal to angle A1. Okay? What's the reason for that? Because I've got opposite angles equal opposite sides. So opposite angles equal angles, not opposite. Equal angles, opposite, equal sides. Okay? Put a line here. Okay? So those two angles are the same. But now what do I know about angle B plus A1, okay, plus O1, okay, and I know O1 is already 90, so let's write 90. All together, they add up to 180. Sum of angles in triangle. I'm not going to write it down, but you need to write sum of angles triangle. But B is equal to A1, so I can write 2A1, it's A1 plus A1, plus 90 equal 180. That means, and I'm running out of space here, 2A1 equal 90. I just move the 90 to the other side. And the last bit here, will you see if I write A1 is equal to 45. A1 is equal to 45. So from here, I'm just going to carry on orally. I'm not going to write it down. So if this is 45, you know this is also 45. Okay? The next thing you want to know is what A2 is. Now, I will personally say, okay, A1 must be equal to A2. How do I know these two angles are the same? Well, we proved that this triangle, ABO, is congruent to AOC. I proved it here. So if this is 45, this is also going to be 45. And therefore, angle A is 45 plus 45, 90 degrees. So, tough, guys. Just to summarize here, this whole exercise 5 is, let's be honest, a little bit beyond most of us here. Okay, it's a bit difficult. If you get a question like that, if you can get 2 marks out of 5, I'll be extremely, extremely happy. It's fine. We're just trying to stay alive there. Get the easier question 100%. The tough question, if we can get 1 or 2 marks, just try and find out, you know, certain things that are equal. If you just write it's equal because it's given, boom, you got a mark. If you can try and figure out which triangle we need to prove that congruent here, you can get that. Okay, great. Okay, if you just score a couple marks, you don't get the whole question, seriously, don't worry about it. Okay, these are the tough questions, the tough one. Okay, that's it. Okay, that's it for it. No more anymore. I'll see you in the next lesson with when we're going to talk. We left congruency. We're going to move to similar triangles. Take care. Bye bye.